Hi guys, welcome. I hope all of you are looking into the videos of the PSM resident class. If you're not, I guess you're missing out on this. And this particular video is on a very interesting topic which you must be knowing. And if you don't, just watch this video and enjoy the video. If you have any queries, any doubts, or any particular topic you want me to teach, you can just drop me a message on my WhatsApp number. The details are given below. Yes, guys? Okay. Now we would look into a very important statistical test called as ANOVA. Now what is ANOVA? It refers to analysis of variance. So ANOVA. Together this makes it as ANOVA, analysis of variance. Now guys, we have different types of ANOVA. We will first discuss about a one-way ANOVA. We also have something called as a MANOVA. So now we look into one-way ANOVA first. Yes. So basically, what does this ANOVA test? This ANOVA basically tests for statistical difference between more than or equal to three groups. Yes guys. Now that too, it is for quantitative data. So it basically would be using the mean parameter for comparison, because ANOVA is done when the output variable is a quantitative data. Yes guys, let us look into an example. You want to know the difference in application of fertilizer. Suppose there are three, A, B, C, on plant growth. Yes guys, so this can help you to understand how well the plants have shown growth by application of different types of fertilizer. Yes guys, now before I take you into further detail, let me first tell you what is the basic difference between ANOVA and a t-test. Yes, so a ANOVA basically is for more than or three groups. T-test is basically for two groups. That's the only difference. Yes, otherwise all other conditions of a t-test would hold true for a ANOVA. Yes. Now, so what will be my hypothesis for ANOVA? My null hypothesis is that the mean values are equal, like mu1 is equal to mu2 equal to mu3 equal to mu k. Yes guys, So what will be my alternate hypothesis? My alternate hypothesis will be that the mean values are not equal. Not all also, even one if not equal, it will become a alternate hypothesis. Yes, no problem in this. So what are the assumptions which we take? Assumptions of an ANOVA. Now, so basically in the assumptions we are having a look, that is first, now level of measurement. My independent variable should be a nominal variable, whereas the dependent variable should be a metric variable. Like in our example of the flower which we had seen, my independent variable was application of fertilizer and dependent variable was growth in centimeter. Similarly, suppose I have another example that I am looking into a group of few people who are hypertensives and I give them 3 drugs, drug A, B, C, and I look into the change in BP, mean change in BP. So again the independent variable for them would be the drug, and the mean change in BP in mm of mercury would become the dependent variable over here. I hope I am clear with this. Yes guys. So the first is the level of measurement should be absolutely clear. Second, there has to be a independence, that is it should be independent in each groups, that is the data should be unpaired or unrelated, because the moment it becomes a paired or related data, we cannot use the one-way ANOVA, rather we go ahead to use MANOVA, which is multi-way ANOVA. Third, it should have a normal distribution of data. Fourth, the variance in each group should roughly be the same. That is, the data should have homogeneity. If no homogeneity, then again the variant which is used is something called as a Welch ANOVA. is something called as a Welch ANOVA. Similarly, if non-normal, then the test which we use is called as Kruskal values. So guys, you have seen I have given you the different assumptions, and if the assumptions are not met, what are the other tests to be done? I have told you that also. Now let us see how does this ANOVA actually work. Okay, so how does this ANOVA actually work? Now guys, basically we have to see between the variance between the groups and also the variance within the group. Now this gives me the F-statistic which is specific for ANOVA. So I introduced two words to you. One was between the groups, one was within the group. Let us see what do I exactly mean with these two. Now when we talk about within the group, this basically measures how much data points within each group fluctuate. Yes, and when we look into between, this tells you how much the mean values, of group differs from each other. Yes guys, I hope I am clear with this. This is a very important understanding. Yes, now you can have the between and with F. Imagine if you have between that is small and width that is large, then automatically the F statistics will be small. Simple basic maths. Or vice versa can also be observed. From this we get a p-value and we calculate whether it is significant or not. Let me help you out with an example. Now suppose we have three groups: group 1, group 2 and group 3. Now so values are something like this. Ten, 9, 9, 8, 7, 8, 6, 7, 7, 6, 7, 6, 5, 4, 3, 6. Something like this. Yes guys, here if you see we have values for each of the 3 groups. Yes. So the first step will be, we have to get the total mean and also the total mean of individual groups. Normally, how do we calculate mean? Add or divide by the sample size. So guys, this is not that tough. Now, how to get the total mean? It will be the sum of all the data divided by the net sample size. So as you can see, 1, 2, 3, 4, 5, 6, 7, 8. Total there are 24 people. The net sample size is 24. And when I add all the values of all the 3 groups, I get a mean value of 5.3. Yes, I get a mean value of 5.3. Now, the mean value of independent groups. So for the group 1, it was 2.5. For the group 2, it was 8. For the group 3, it was 5.5. Simple mathematical calculations by adding these values. Yes guys. Now going to the next step, that is the step number 2. Okay guys, so now you can see we have 3 values over here for M1, M2, M3. We also have the value of G coefficient, which is 5.3. Okay, so as of now we have this and this entire table. Now guys, we are trying to make this particular calculation. This is optional. If you can get it, it is great. Otherwise you may ignore the same. Okay, now we look into step 2. What would we do further? Yes guys, now since we have already calculated the mean, we will go ahead and calculate the sum of squares between the groups. Now how will we calculate the sum of squares? To calculate the sum of squares, we can calculate the difference between each group mean, and the total mean square, and add up. That means we calculate the SS between, which is a sum total of groups NI MI minus G square. Now what is this sum over here? This sum basically refers to the number of values in each group. Now guys, in the example ahead, the number of values 1, 2, 3, 4, 5, 6, 7, 8. We had 8 values in each group. Now here for M1 it is 2.5 and my G value is 5.3. So it will be 2.5 minus 5.3 whole square. Similarly for M2, I will have 8 minus 5.3 whole square plus, because for M2 this value was 8, for M3 it is 5.5. So 5.5 minus 5.3 whole square. When I do this, the grand total will come out as 121.3. Now guys, in your exam, especially in your final MD exam, in the practicals, you would get a practical sum to probably do a ANOVA. At that time, many times, you should know this. The calculation will be easier. They will give you a calculator, but you should know this for that purpose. Yes. Now, once this is done, we go into the step 3. So, in the step 3, basically what we do, we calculate the sum of squares within the groups. Now, to do this, we basically subtract the mean of each group from each individual values of that group, which means we subtract the mean of first group from each of its values, then mean of second group from each of its values, and mean of third group from each of values, and then we square the difference obtained. So basically guys, for this particular one, it is a summation of both the group X mi minus own mi by 2. So what we do, going up, so this was 3.5, this is 3, so I'll have 3.3 minus 2.5 whole square. Next is 2 minus 2.5 whole square. I'll do all this manually. So 3 minus 2.5 whole square plus 2 minus 2.5 whole square. Similarly, for the next group, I'll do the same thing. Similarly, for the third group, I'll do the same thing. And finally, I get a value, suppose 36. Yes. Now guys, because we have calculated the total mean and the group value mean, we have also calculated the sum of squares between the groups and within the groups. Now we can calculate the variances within and with the group. So step number 4 is to calculate the variances within and between the groups. This is done by taking between the group divided by the degree of freedom. So this value is the sum of squares between group. Like in this condition, we had calculated the sum of square which had come over here as 121.3. So the value of this is 121.3, and the degree of freedom. So there are total 3 groups. So we know degree of freedom is the number of groups minus 1. So this is number of groups minus 1. So this becomes 3 minus 1, and this is mean squares between the groups. So this value comes out as 121.3 by 2, which comes out as 60.67. Similarly, we will calculate for in between the group in a same manner. My value was 26 by 21. Because the degree of freedom, there were total 24 values minus 3. This gives me 1.71. Now the F statistic, which is the value of M between the group and M within the group. 60.67 by 1.71. This gives me 35.39. This is the variance within groups, and this is the variance between groups. After we get this F value, we calculate the P value with F distribution. It tells you significance. So this will tell you significance. Present or absent. But there comes a limitation, that is, it doesn't tell which group differs, and for this we use a very important Viva question, a SR-ship question of INICET, a DM question for your DM entrances related to public health. We use the Bone-Ferroni post hoc test. This, my dear students, is all about one-way ANOVA. Upcoming will be MANOVA, but before that, the most common MANOVA is a two-way ANOVA. That is what we are going to experience in the next topic. Yes, guys, the calculation is tough, but do not worry. Calculation is optional, but these things you should know as a PSM postgraduate. Okay, guys? Okay, guys, now let us have a look into the elder brother to probably one-way ANOVA, that is a two-way ANOVA. Now, so basically a two-way ANOVA is definitely a statistical test which is used to measure the effect of two categorical variables on a continuous variable. Now remember, this categorical variable is basically my independent variable. Like, for example, I am having a look at the drug type AB versus the response gender wise. How would it vary in a male versus a female? Yes, and the continuous variable is the dependent variable. Example, the reduction in the blood pressure. Yes guys, so a two-way ANOVA gives you this particular statistical association. Now if you ask me, I would also say this is an extension of the one-way ANOVA. Why? One way versus two way. This one-way ANOVA basically tells you about impact of a single independent variable on a dependent variable. Whereas in a two-way, we look into the impact of two independent variables and these independent variables are labeled as factors. Like in the example above, the type of therapy, suppose A, B, C, about gender male and female, these all are called as factors. Yes. So basically over here we are trying to see if the factor has any impact, has an effect on dependent variable. Yes guys. So in a nutshell, this gives you a very simple understanding about where we do a two-way ANOVA. Yes. Now when do we do the two-way ANOVA? This two-way ANOVA basically we do when we have a second factor and we want to know if this factor also has an impact on dependent variable. Like if I give you an example, that in addition to gender, does the education level have any impact on the salary? Similarly, we can see if gender and the type of therapy, does it impact the blood pressure? Yes guys, does it impact the blood pressure? Yes guys. Now, in a one-way ANOVA, we would be basically going for one factor which is impacting my group 1, group 2 and group 3. Whereas in the two-way ANOVA, we are seeing two factors impacting, suppose factor A and factor B, impacting the group 1, group 2 and the group 3. So you can see we are having more permutations and combinations to be taken care of, which the two-way ANOVA does for us. Yes. So what kind of statements can we make with a two-way ANOVA? With a two-way ANOVA. So we can make first, does the factor 1 have an effect on the dependent variable? Similarly, does the factor 2 have an effect on the dependent variable? Third, is there an interaction between the factor 1 and factor 2? So in a very simple way, if you ask me, I can tell you that the two-way ANOVA is probably a test which can analyze Ekta Kapoor serials, where multiple people are impacting the overall status of how the serial will go ahead. So two-way ANOVA is like BAP of all, which can actually analyze many different types of quantitative data. Now, so what will be my hypothesis in a two-way ANOVA? So in a two-way ANOVA, my null hypothesis is going to be that there is no significant difference between groups of first factor and between groups of second factor. Now suppose there would have been n factors, we would have n different null hypotheses. Yes guys. Also that one factor has no effect on the other factor. Yes guys. Now the alternate hypothesis will say there is a significant difference between, again, all these three parameters. I hope I am clear with this. Guys, two-way ANOVA, a very important Viva question. If you want to get a gold medal in your final MD exam, you would probably get a question where the teacher is asking you about a two-way ANOVA, because this is a very complex one per se. Yes, and that's the reason there is no calculation. The way I explained you one-way ANOVA, two-way ANOVA, I'm not telling you the calculations. You will go crazy. I have already gone crazy. Yes guys. Now, what about the assumptions of the two-way ANOVA? First, the first and foremost is the distribution of data is normal. So it should have a normal distribution of data. Also, the residuals which comes in the equations should be normally distributed as well. Now, how do we know this? For this, we draw an image which is called as the QQ plot. That is the quantile plot. SRship MCQ, DM entrance MCQ, the use of a QQ plot to check the distribution of data, whether it is normal or non-normal. Second, the data should have homogeneity. To check this, we do another test which is called as Levene test. So a Levene test tells you whether the data variants are homogeneous. Third, independence. That means impact of one group should not be there on the second group. Yes guys, impact of one group should not be there on other group. Fourth, the measurement level, it should be measured in a metric scale. Yes guys, this, my dear students, is all about two-way ANOVA, and this is all about your short note ANOVA. Probably this would be a short note which probably the examiner expects that you mention about both one way and two way, or they can give you separately about one way alag, two way alag. Yes guys, this is all for this topic. I hope you liked it. Bye bye. See you. Take care. Good night.